Okay, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1108. Let's just jump into it because we had some examples to do from last time. So let's actually talk about those. The screen is being shared. I can see the chart. Let's go. All right. So last time we were doing some linear programming, and we went through very painstakingly set something up. I want to do some more examples today because these problems are very important and they are also one of the longer problem types out there. So you definitely want to practice a lot to make sure that you get them, you can do them quickly, you understand them, all that good stuff. Okay, so one problem that we set up is one to solve the feeding animals at a food shelter farm, the food shelter problem, where the animals had certain dietary requirements, and we had two different kinds of food brands that had various dietary things in them, and so we also had contracts under which we had to serve a certain amount of each type of food. So we wanted to be able to fulfill all our needs, right? The animals get the nutrition they need. We can fulfill all the contracts that we have to buy a certain amount of food and sell a certain amount of food. But at the same time, we also want to do this with minimal cost. Turns out this was a linear programming problem, which we went to set up. And I guess I'll talk a little bit more about getting the initial setup done today as well. Because I did give you the steps for solving a linear programming problem, but there, as you see, there is stuff that comes before it. So usually like setting up some sort of table, or it doesn't even have to be a table, but I find that in a lot of cases, a table is very useful just to kind of have the data organized in your brain to get away from all the text of the word problem, just to kind of write down the essential details. You might want to organize things in a table just to kind of figure out what's going on. So that's something that you might want to do as like a step 0 kind of thing. You are, of course, then going to label your variables, right? So you're going to know, once you understand the problem from setting it up and really understanding where all the numbers are going, you're going to know what you should be looking for. You want to set up your variables, or if you automatically know from the statement of the problem what you want to be looking for, you set up the variables. Then, once you fully understand that, you know what you're calling everything with your variables, then you start going through and checking each requirement, kind of try to set up your inequalities and so on. And that brings you to the linear programming problem, which you're going to set up, and now you have to actually solve it to figure out the answer to the problem. Okay, so we have that. Now, once you do that, of course, you're going to go through the steps that I told you how to actually solve the problem. So you're first going to find the feasible region, which means you're going to draw all the constraints. You're going to shade the region that satisfies all constraints. Okay, cool. 2, you're going to find all the corner points around the edges of the feasible region, because as we saw last time, that's where the answer is going to be. Whether you're maximizing or minimizing doesn't matter. That's where the answer is going to be. It's going to be on the edge somewhere, right? We actually saw that in this class, right? Whether you want the max or the min, you're still going to be doing the same thing, essentially. The process is not going to change. Everything is the same, except at the very last, in step 3, you would actually either pick the smallest thing or the largest thing in that table, right, as is needed. Okay, so you find all the corner points around the edges, then you test all the corner points in your objective function. The objective function is going to be what you want to maximize or minimize. It's this guy right here. Yeah, in this case, we wanted to minimize it. And it turns out that the minimum cost was $1.02 per serving, or per animal, or per meal that you're doing. Okay, so we found that the answer is a cost of $1.02 per serving, with 3 units from food A and 4 units from food B. Okay, so that was the optimal solution. Okay, now I mentioned that I wanted you guys to think about part B of this question, which is not a very typical question I would ask, admittedly, but I thought it was interesting to see if you guys could come up with any ideas about how to actually change things. And because we have a lot of examples to do, and they take a very long time, in the interest of time, I'll probably just point your attention towards where you can be looking. I'm particularly thinking about what we found for food B. So there is some opportunity there, it turns out. So we found that the optimal answer was to buy 3 units of A and 4 units of B. Okay. Now in the problem, what was the problem about? Well, the animals need at least 30 grams of protein and 20 grams of fat. We have 2 different brands of food. Food A, for every unit, you get 2 grams of protein, 4 grams of fat. For B, you get 6 grams of protein, 2 grams of fat. B is the cheaper one, so you're not allowed to use more than 3 times the amount of food B as you would as food A. So you can't do something like, for example, just buy food A, just buy food B like all the time and kind of mix and match it. You have to you have to kind of proportion it differently, right? So that was one question, one restriction. Another restriction was you're required by contract to buy at least 2 units of food B. Anything you think that could make this situation a little better, given all that, given all our requirements, and given that we know what's best for us to do? Anything you would think that we could do here? Ideas. And we're really focusing on food B. So we don't want more than 3 times food B as food A, as well as we're required to buy 2 units of food B. But I noticed that it's in my interest to buy 4 units of food B. Anything we can do with that? And don't really think in terms of math, because it's not, at this point, it's not a math question. Like, I haven't taught you any math that's going to be able to answer that question. This is about, trying to be practical. Imagine you were this guy, you were the owner of this rescue center. You know all your requirements, and you know what's best for your rescue center. Given all these facts, any decisions you would make, anything you would try to do to make things even better? So I asked my last class this. You guys are actually a little bit a smaller of a class, so I don't know how many. But any of you guys have a Costco membership? Or maybe your parents have a Costco membership or anything like that? Or BJ's or one of those things?
BJ's.
Yeah? Okay. Yeah. Like, what's the benefit? Like what?
Isn't it like if you have a membership, it's like a lot of it's a lot of products in bundles and it's cheaper.
Right, because exactly, when you're buying in bulk, things are cheaper, right? Like if you're buying more, and this is again, one of another economics kind of things, like if you're willing to buy more things from a supplier, like they would be willing to lower the price per unit, right? So it's like by buying in bulk, you can actually save even more money. So knowing that, right? Knowing that, okay, I'm required to have 2 units of food B, but it's actually better for me to buy 4 units of food B, right? What would you think? Like, what is something to do, right? Going by that kind of Costco / BJ's mentality, right? So the idea would be, it's actually better to like buy B in more bulk, and then you could probably even get it for a cheaper price. Maybe even go back to the supplier you were in business with and do a renegotiation, right? So this guy's like, hey man, got quality food here, and selling it for cheap, dirt cheap. You can get units of me. I'll give you for 12 cents a pop. And you're like, it's pretty good, man. Because, this other, you have to talk and you have to schmooze and you have to kind of like, see where you're coming, man. I really appreciate you're doing that. Like, down the road, old McDonald, that guy down there, he's selling me for like 18 cents. And it's like, man, that's crazy, man. That guy, he has the cow that goes moo moo. And I'm like, yeah, I saw the cow that goes moo moo. Kind of smooth. And you're like, but you know what? I like doing business with you. So how about you double my order and, shave a little bit more off the price? Give it for 10 cents, 9 cents. I'll double it. I'm not going to buy 2 units. I'll buy 4. Just, and what happens? You get more of the food you need because it's actually optimal for you. It's the best thing for you to have 4 units instead of 2, right? It's literally cheaper for you that way. And you can fulfill all your requirements. Your animals get all the nutrition they need. And it's better for the supplier because now he's selling twice as many goods as he would have sold otherwise. So now by examining the math, you kind of have this opportunity for like a win-win. You can like even strengthen your business relationship even more because you're like, hey, like, I'm gonna buy more of your stuff, man. Help me out. You get things cheaper. He sells more of his stuff. Everybody's happy, right? And it's not like you're trying to pull one over on on someone in your business relationship. It's like you're literally doing something that will benefit the both of you, right? Which is awesome, right? Whenever that happens in business, when you can make a relationship stronger, everyone's more friendly. It's not always a cutthroat thing. There are times when you have win-win situations, right? Where it's like, it's actually better for me to do better for you. That happens every now and then. And I just thought that was an interesting spin on this problem. So yeah. So knowing that you have to buy more than you're required to buy kind of puts you in the situation where you can kind of negotiate in terms of bulk. You can kind of come to someone and say, you know what, I like you. I like how you do business, sir. So want to be in bigger business with you. If we're going to do this, let's go big. Give me 4 units, double your units, shave a little bit more off the top. I'll keep coming back every month, buy a bunch of stuff from you. Sounds good. All right, shake your hands and yeah, you guys, every weekend you go, you guys both make fun of old McDonald's. It's good. It's just good times all around, right? Of course, when you're with old McDonald, you make fun of that guy. I'm just kidding. Okay, but yeah, I just thought that was an interesting spin on the problem. But for now, we're going to do these guys. And in the other class, probably because I was rambling so much about old McDonald, we didn't actually finish the third one. So I'm going to leave that for you guys to try. And I guess I can use that as a segue into the stuff that we want to do next week, next class, Tuesday. So probably what I would actually recommend that you do is that you're going to do this one on your own over the weekend by hand, just for extra practice. And then we'd probably set it up and actually solve it with Excel or Python, just for you to see how it would go. So the setup would be the same. Like you'd have to set that up on your own. But once you actually have the linear programming problem itself, like I know I want to maximize these. I know these are my constraints. That's when the computer can come in and you can actually get something done. So that ought to be interesting. But I think we will get through the first 2. So let's actually jump into that. Okay, here's an example about investing in pension funds. So a pension fund manager decides to invest a total of, at most, 30 million into bonds, US Treasury bonds, paying 4% annual interest, and in mutual funds that pay 8% annual interest, right? So there are 2 different types of investments that this person is considering for his $30 million. At most $30 million. He might decide to invest less depending on what's going on or what he can get away with. Okay. He does know that he does want some exposure to these funds though. So he says like, you know what, I'm definitely going to buy at least 5 million of one. I'm going to buy at least 5 million in bonds. Bonds are the safer investment generally. You won't get a lot of growth out of them, but they don't crash like the stock market. Usually it's safer. It's less risk to go into bonds because pretty much you're having things guaranteed by the U.S. government, which for the foreseeable future will be solvent. No comment. Okay, so or you can. He wants to invest at least 10 million in mutual funds. So mutual funds is like a basket of stocks. So it's like one thing that you can buy, but it's already diversified. So you had a mutual fund manager already went through and picked a bunch of different stocks. It could be 30, 100, 1,000, a bunch of different stocks, put them all in one bag, and then sells that bag. So how all those companies do combined is how you're going to do when you buy that mutual fund. So you want at least 5 million in bonds and 10 million in mutual funds. However, no one's going to give you anything for free. There are fees to this. So you will pay $100 for each $1 million spent in for the bonds, right? So it's like a 0.1% like interest fee or something like that. And you'll have to pay $200 per million that you invest in mutual funds, right? But this guy, the pension fund manager, he went to 1108 class where he learned that, man, fees can really kill you. They can steal like 2/3 of my gains. So I'm not going to like sleep on this. I'm going to limit my fees. I'm going to make sure that I never pay more than $5,000 in fees. So this is a restriction of his. Like, I know what I want. I know how much I want to buy roughly, but I'm not going to buy a bunch of stuff and not care about how much it's costing me to buy them. No one would do that. Like, why would you do that? Like, I'm really going to take cost into account. So I want to keep my fees under 5,000 for this investment. Now, the question is, how much should be invested in each to maximize annual interest? And what is the maximum annual interest? So let's actually do that. So here, we kind of already know what we're after, so we can actually set up our variables right away, I guess. Let's do that. So let X be the amount invested in bonds. Let Y be the amount invested in mutual funds. Right? Which is, again, pretty safe. Like I said, it's a basket of stocks, which is very good. A lot of times not as good as the entire market. So I don't know if there's a pretty famous bet that Warren Buffett made with a bunch of hedge fund managers a while back. Like it was like 10 years ago or something like that. He bet them $1 million that if they could beat the stock market. So Warren Buffett was like, he put his money on the S&P 500, which just is a basket of the top 500 companies, most profitable companies in America at any given time, right? So you track the valuation, the most profitable and the largest companies, and you keep the top 500 in a group. People can fall out of this group and then other people enter the group, but the idea is whatever the top 500 is, that's what you're looking at. That's the S&P 500. And so he went to all these, fancy money managers and things of that sort. And he's like, you know what, let's make a bet. Let's see who's better, the market or you guys. And he ended up winning. So it turns out sometimes just putting your money in the market into a mutual fund or an index fund or whatever is actually better than having someone who claims to be a financial expert pick individual stocks for you and pick individuals and just try to say, yeah, this is the next big thing, man. Let's invest in this. Like usually they'll have a lot of reasons for why they want to do something, but it's usually not going to perform better than someone just taking up a whole wide array of different stocks and just putting them in one thing. So yeah, so this guy he's thinking in the right direction. Let's see what's best for him. So here, like I said, we're going to organize the data. So what we're going to do here is choose variables. just kind of looking at the initial setup, organize the data, which could be done in a table, which there's not much to put in the table here, but I guess I'll just highlight some of the things that we see. So, I don't know, like requirements or wants. US bonds. And mutual funds. So what are the important things? The interest I care about. The whole point is to maximize the interest that I'm getting. How much interest am I getting? Well, for bonds, I'm getting 4%, which is actually a pretty decent, reasonable number. I mean, for bonds, you'll get anywhere between 2 and 4%, something like that. Average 3, 3.5, something like that. And a lot of times with US Treasury bonds, you don't have to pay taxes on them, pro tip, right? So there are times when you you invest in certain things and you have to pay taxes on top of it, even when you make gains. There are a lot of times, municipal bonds, you can invest in New York City, you can invest in US Treasury bonds, and it's like, when you make the gains, you don't have to pay taxes on it. So that's something, you'd have to look into that individually though, because sometimes you do, sometimes you don't, but that's just another thing. However, in this made up problem, we get 4% returns, whereas we get 8% returns on the mutual funds. Let's see, what else do we know? We know the minimum we want to invest, min to invest. We want at least 5 million here, and we want at least 10 million here. Okay, what else? Fees, very important. Pay attention to fees. So this is 100. This is 100 per mil. And this one is 200 per mil. What else? Well, I do know that combined, by these powers combined, I want to spend less than or equal to $5,000. And if I'm like amount bought, this is X, this is Y. I would also know that the combined amount should be less than 30 mil. So let X and Y be the investment in bonds. Let's put some units on this in millions. Is that all our stuff? Yes. Okay, so here's what we're going to do. So from this, there's nothing much to say here. So then you set up the LP objective. What do we want to do? We want to maximize interest. Now for interest, I get 4% from bonds, 8% from mutual funds, which means I want to maximize 4% of this plus 8% of that. And that would be the maximum annual interest. What is the maximum annual interest? Okay, and then subject to, let's do our restrictions here. Minimum to, we know that x plus y should be less than or equal to 30 mil. We also know that for each million, I'm paying $100 for x. For each million, I'm paying $200 for y, and I want that to be less than or equal to $5,000. What else? I want at least 5 of x and at least 10 of y. What else? That's it. I mean, we get these for free. The non-negativity requirements, x greater than or equal to 0, y greater than or equal to 0. It's automatic. Because that's, right, if we're bigger than 5 and 10 respectively, we're both bigger than 0. So we also have the non-negativity required invested for getting for free. So now we go into step 1, feasible region. Okay. So what we'll be doing next week, like I said, we will learn how to solve these in like a computer situation. And so where that would come in is after this point. After you actually set up the problem, then you're going to enter all this stuff into Excel to kind of see what the best thing was. And Excel will actually do something in the background for you and then give you the answer. But we are going to do this by hand because we're going to need to know how to do that for the test. So let's do that. Y. So 30 million, x plus y equals 30 million. Okay, here, it's 30 mil. Here, 30 mil. What else? 100x plus 200y is less than 5,000. Plug in y equals 0. Our x would be 50. And plug in x equals 0. Our y would be 25. I don't know if this is where these guys are going to intersect or what. I'm just not drawn to scale. Okay. Then when my x be greater than 5, so it's going to be that way. And I want my y to be greater than or equal to 10. So I'd actually want to know where these guys are going to, is this at a level 10 or higher? Yeah, maybe I'll need to find that to see. Should the horizontal line for the 10 be above or below that? Like I don't actually know. So let's actually start off the corner point section, so the second thing we'd want to do is find the corner points. But let's find this one first. So I want to intersect x equals 5 with, I should have been labeling these guys. So this is x plus y equals 30. This here is 100x plus 200y equals 5,000. Okay, so x equals 5, and then I have 100 x plus 200 y equals 5,000. Of course, I can just plug this guy into there. So this is going to be 500. Do roughly 22.5. Okay, so that is at level 22.5.
Professor,
Yeah.
on the exam, can we use our calculators to find the intersections?
What do you mean?
Like instead of writing it all out, like just plugging it into our calculators to find where the two lines intersect?
Do you have a calculator that can do that? Like, like you enter the system and it tells you the answers?
Yeah.
Yeah, I guess that's fine.
Okay, thank you.
So that's 22.5, which means the y equals 10 line will be below that. This is y equals 10. Okay, so we have that. Now, let's see, where do we want to be? Where are we? Okay, yes, x plus y is less than 30 mils, so we definitely want to be below this guy. We want to be to the right of that. We want to be above this. We also want to be below this guy. Okay, so what is satisfied by everyone? Looks like this triangle right here. So we need 2 more corner points. So one, you can have x, undo. So one, you can have x is 5 and y is 22.5. Another one is, again, x is 5. And I would intersect that with, that intersects with y equals 10, right? That was actually for free. Then there's going to be another line. So this is the first one. This is the 5, 10 is the second one. And then for the third one, we're going to intersect the 100x, 100x plus 200y equals 5,000, and intersect that with y equals 10. So of course, I'm going to plug that in. I already know my y is 10. So I would have 100x plus 2,000 equals 5,000. So this means 100x equals, well, 3,000. And so x equals 30. which that edge doesn't seem to work. No, I hope I shaded the right thing here. Is it at most or at least? He plans to invest at least and at least, which means less than or equal to. Greater than or equal to. I know. I hope I meant to write that out that way, because that point seems like it's kind of off, because this is already at 30 right here. Anyway, moving on to, we are going to check 3. We are going to test the points. So we would have, X, Y, Z. Five and 22.5, 5 and 10. And that's the only one that's relevant. Here we have 0.4x plus 0.08y. And we want to plug this in. I think I got 2 here. Of course, that's in like millions. And I hate using my phone for a calculator. Times got 1 here. So maximum, want this guy. So max interest made, max amount from interest is 2 mil, with 5 mil in bonds, 22.5 mil in funds, max interest rate. Well, you just take that 2 mil divided by the total that you put in. And it'll tell you how much interest you actually made. Yeah, that's one of them. Which, the third point not fitting is kind of weird. I think I messed up in the question somewhere. Let's move on to this one. This one's a little easier, and it's actually probably closer to what I would give you in a test, I think. So let's actually look at that one. All right. So here we are buying insurance Companies considering 2 insurance plans with 2 types of coverage per unit bought. The premiums are shown below. So you have policy A or policy B. Policy A will give you $10,000 in fire and theft coverage, $180,000 in liability. So if you have a fire or theft, they'll give you $10,000 to replace what you've lost. Or, you know, if you're sued for liability or whatever, they'll pay $180,000. But it will cost you, the premiums are the fees, by the way. That's what premium of an insurance is. So it's like your monthly insurance bill. And that will cost $50, what I just said. Policy B, you get $15,000 in fire and theft, and you get $120,000 in liability, and that will cost you $40 per month or whatever. Now, as a company, you want to have at least $300,000 in fire and theft insurance and $3 million in liability coverage. How many units of each plan should be purchased to minimize the premium cost? So that's what we want to do. Now, this is already nicely organized in a table for us. So just we'll jump into it with identifying our variables. Let X be units of A bought. Let Y be units of B bought. What do we know? Objective. We want to minimize the premium cost. Which here, for each unit of A that I buy, I have to pay 50. For each unit of Y that I buy, I have to pay 40. Subject to, what are my restrictions? I want at least 300,000 in fire and theft. For policy A, I get 10,000. For policy B, I get 15,000. And I want at least 300,000. And that's for fire theft. We have liability, 180,000 and 120,000, want at least 3 million. So we have 180,000, 120,000. We want that to be at least 3 million. And that's all we care about. Of course, you have to have some insurance. You can't have no insurance. So we're definitely buying something. And we can't buy a negative amount of that thing. Can't go to the insurance company and be like, you pay me to have your insurance. Like, you can't do that. So that's that. So now you jump into the process. We know that first we're going to find the feasible region. Now, these numbers are kind of big, and so I'd probably reduce this rewrite. So for this one, notice that I can divide both sides by 1,000, and then I can divide again by 5. So what I'm going to do is I'm going to divide this by 5,000. And that would leave me with 2x plus 3y is greater than or equal to 60. 5 into 30 goes 6 times. Okay. Then for this one, divide by, and for this one, can divide by 10,000, it looks like. And then 6 would go into everything. So I'm going to divide by 60,000. on both sides. So 3, 6 is 18, so this is 3x plus 2y greater than or equal to 50, looks like. Okay, so those numbers are nicer, they're smaller. Let's go with those. So I need 2x plus 3y equals 60. So y equals 0 means my x is 30 and y is 20. And 3x plus 2y equals 50. So my y is going to be 25 and my x is going to be 50 over 3. And 50 over 3 is roughly 16. Okay, so 50 over 3, that's roughly, 16.66. Okay, so that's that. I know I want to be above all of these. So I want to be to the right of that, I want to be up here, I want to be above this line, I want to be above that line. So my feasible region is this whole thing right here. It's an unbounded feasible region, but it's okay because we're minimizing here and we're minimizing a line that's slanted this way. So there are 3 corner points to worry about. 2 of them are obvious because they're intercepts. The third one isn't. So 2 corner points. So one is we have 30, 0 and 25. 0, 25. For the third one, I'm going to intersect these 2 lines. So what I can do is this is 6x plus 9y equals 180. So this is equation 1, that's equation 2. What I just did is I took equation 1 times 3. Then this is minus 6x minus 4y minus 100. Took equation 2 times minus 2. Can add these. I would get 5y equals 80. So y equals 16. And so then my x would be, well, 60 minus 3 times 16 all over 2. Which is 6. So I would get 6, 16 for the last one. So now we're going to test those. Six, 16, 30, 0, 0, 25 into 50x plus 40y. And that'll be 50 times 6 plus 40 times 16, got 940. Or I can have 30 times 50. Or I can have 25 times 40. And we want to minimize the cost. It's going to be this guy. And so now that's the answer. min cost is 940 with 6 units of A and 16 units of B. Yeah. So next thing for you guys to do is to try this one. And we'll actually look at it on Monday. And I think it'll be nice for you to, of course, do it by hand because you're going to need the practice, but also probably would also solve the same problem in Excel, just for you to, as a nice segue into that section. So we'll wrap up there. I'll leave this here for a while so you guys can take a screenshot. But after that, I'll let you guys go. So yes, that's it for today. Hopefully that was informative. Yeah. So I'll see you guys on Tuesday. Try this one by hand. We'll solve it on Tuesday and look into Excel and or Python. And then by Wednesday, we're actually probably going to break into another topic. So this is going to be the end of chapter 5. Very important stuff, but it's also very long and hard problems on an exam. So definitely get your practice in, and I'll see you guys in the next one.